Hello, Geometry. This is the final lesson in Chapter 8, Proportionality Theorems. We're going to see a lot of triangles and different shapes that have parallel lines and setting up formulas and a lot of proportions of similar figures that are drawn here. Okay, so if we have these parallel lines like we have on page 236, you have two similar triangles, that being ADE. Triangle ADE is similar to triangle ABC. Okay, we've shown that already. We're comparing now some of these individual parts. So let's say they're going to be like, okay, if this is 2 and this is 4, if this is 3, see how you have 2 times 2 is 4, 3 times 2, this would be 6. It's not 3 times 3. There's a scale factor going on there. Okay, so we get from here is like if I take AD over DB, AD over DB, that would equal AE over the corresponding part to BD would be CE. Okay, so those sort of proportions are what we're doing and working with today, and there's several different ways we can set that up. The other type of picture you're going to see is a triangle that has an angle bisector. So something that will be given is an angle bisector, and it's going to cut the opposite sides proportional to the sides that they're related to over here. Okay, this is going to be showing up here in Theorem 8.9, which is referred to as the angle bisector theorem. Okay, so if you're going to take, what's going to happen here is if you're going to take AD and compare it to its other side, so here's the angle bisector going in, AD over DC, that is going to equal the corresponding side to AD, which is AB, over the corresponding side to DC, which is BC. Okay, so AD over DC equals AB over BC. Now understand there's different ways to write those, and we'll write all of those down as we get to these definitions here. Okay, so on to page 238, triangle proportionality theorem. If a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So if a line is parallel to one side of the triangle, it's going to cut it there proportionally. So if TU is parallel to QS, then RT over TQ is what we're just looking at. RT over TQ equals RU over US. Okay, there's other ways you can write that. I could write it as RT over RU. I could take RT over RU, and that could equal, RT over RU would be TQ over US. Okay, it would have to be TQ over US, not US over TQ, because I wrote RT on top here. That basically is just taking these two parts and that's interchanging them. Okay, you can do that proportion. The other thing I want to look at, which will serve this example well, is you can take RT over the total length over RQ. RT over RQ equals RU, are you fascinated, over RS. Okay, RU over S. So you can take a part over the whole. So that's what we have going on here, is we have a 3, we have a 9. Now there's a couple ways you can go about it. You can use the entire parts here, but if you do that, then you have to write a new expression here, which is x plus 2, and you're going to get into a little bit more algebra, which is definitely possible, you can do it, but you'd have to do 3 over 9 equals 2 over x plus 2, and then you can solve for x. What I would do in this case is if that's the total length is 9 and that's 3, I would know that this side right here would be 6. Okay, 3 plus 9 is 6. And then we can set it up. 3 over 6 equals 2 over x. Okay, so you see the bottom number is twice the top number. So the bottom number here, x, would have to be 4. It has to be 4. You can also cross multiply and divide. 3x equals 12. Boom, boom. So x equals 4. The converse of the triangle proportionality theorem, number 1, if a line divides two sides of a triangle proportionally, that word there, number 1, then it is parallel to the third side. Okay, that's the converse of the triangle proportionality theorem. So the questions here would say, given the proportional, is BD parallel to AE? So they're giving us all these different sides. Is BD parallel to AE? So you just have to ask yourself, does CB over BA equal CD over DE? Okay, are they proportional? So we check 2.5 over 10. Does that equal 2 over 8? Now, if you're not sure how to check proportions, if you're not comfortable with that, an easy way to do that is just to cross multiply. And we call that the cross product, and that must be equal. Cross product must be equal. So I'm going to take 2.5 times 8. That's going to give me 20. So 2.5 times 8, that direction. I'm going to take 2 times 10, and that gives me 20. 2 times 10 equals 20. So are they parallel? We would say yes, they are parallel, up there on top. Okay, these are the same ones that are going to be over here. They said RT over TQ. You can set up the same proportions down here. Okay, those are the same. It could be RT over RU equals TQ over US, or you can look at the total lengths. RT over RQ equals RU over RS. Okay? Triangle proportionality theorems. So setting up proportions and solving them. We'll get back to that example here in a little bit. Three parallel lines theorem. If 3 parallel lines intersect 2 transversals, then they divide the transversals proportionally. Okay? So here we have 3 parallel lines. L and M are not parallel. They are not parallel. And they say UW over WY, UW over WY equals VX over XZ. Okay. Again, we can set it up a different way by changing out on the diagonal. UW over VX, you could go UW over VX equals WY over XZ. WY over XZ. So you can go this over this equals that over that, or this over that equals this over that. If you got one line this and then one line that. Okay. So, not sure if I really drew this the right way, but this will work. Going on here, we have 3 and 1. These are parallel lines cut by these 3 lines here. So 3 over 1 equals 4.5 over x. Okay, 3 over 1 equals 4.5 over x. Cross multiply or do the z method. 3x equals 4.5. We're going to divide that by 3. 3 divided by 4.5, that'd be 45 over 30. And 15 goes in there, 3 over 2. So x would equal 1.5. You can definitely use a calculator to get that. Okay, so x would equal 1.5 with that. Triangle angle bisector theorem. This is one we saw earlier. We have AD over DB equals CA over CB. Again, interchange those. We could say AD over CA equals DB over BC, or CB. Okay, so you have different ways to set this up. So when we have this, we're looking for x. I could say x over 7 equals 22 over 16. 22 would have to be on top because it corresponds with the x. Or I could say x over 22 equals 7 over 16. Okay, so let's just go that way. X over 22 equals 7 over 16. Cross multiply. We get 16x equals 22 times 7. That'd be 140. 20 times 7 is 140. 2 times 7 is 14. 140 plus 14 would be 154. And then divide by 16. Can't do that as well. X equals 9.625. 9 and 5/8 would be that number. Okay, lovely decimal. Okay, so these questions here, these are ones that you'll have that are not in our student journal. It says, which diagram shows point P dividing AB into the given ratio? So these are constructions that you can do with a compass and straight edge. Most likely won't do them in class. But what these questions are asking is, this point B, they want it to divide here. You see how that's 2 and that's 3? That's a ratio of 2 to 3. So the ratio of 2 to 3 is that one right there. That's all you're doing right here. You're checking that. So here, when I see point B, it's 1, 2, 3, 4. That's 4 to 1. So 4 to 1 measures that one right there. Here, down here, not too high, I guess, there's 2 and there's 2. Well, 2 to 2 reduces to 1 to 1. So 1 to 1 would be this one. And then this final one is 1 to 2. Oops, that should be 2 there. It should be from 1 to 2. So 1 to 2 would be that one. So you asked a few questions on there. Just make sure the number of spaces in front of point P matches the first given ratio, first number, and the number of spaces after point B matches the second number. Okay, find the length of AB, page 239. We're almost there, almost done with chapter 8, this part of it. They want the length from A to B. So that's going to be my X. I know 6, I know 10, I know 5. We have parallel lines right here. So I can say X over 5 or X over 6, doesn't matter. If I go X over 6, then I have to come back, I have to do 5 over 10. Now 5 over 10 is half, so the top number is half the bottom number. X has to equal 3. So AB equals 3. Notice I didn't put the segment on top because they wanted a length. AB equals 3. Okay, here's AB again, same sort of setup. This time I'm going to take it the other direction. I'm going to say X over 2. And that has to equal 9 over 7 or 7 over 9. Well, since I started with X, it has to equal this 7 over 9. Okay, it's kind of a weird fraction. You just cross multiply, use the Z method. 9x equals 14. X is going to equal 14 ninths. Okay, that fraction is going to be weird. We're going to leave it just, it's going to be a repeating decimal like that. So we're just going to leave it as 14 ninths. It stays as a fraction. This is the converse. Now it says determine whether they are parallel. So we check the proportions. Check proportions. So I'm just going to go down the row over here. Does 3 over 4 equal 4 over 5? Okay, 3 over 4 equal 4 over 5. Okay, we know those fractions. That's 3/4, that's 4/5. They are not the same fractions. So no, and they are not parallel. Again, if you have trouble recognizing that, just cross multiply. 3 times 5 is 15. 4 times 4 is 16. Those are not equal, so they're not parallel. So that one's no. I'm going to guess number 4 is yes. Let's check it. Let's set it up a different way here. You can go 6 over 4 equals 7.5 over 5. I'm going to set it up 7.5 over 6. I started with 7.5. I'm going to go back to the 5. Does that equal 5 over 4? That's the question there. Cross multiply. 7.5 times 4. Well, 7 times 4 is 28. 0.5 times 4 is 2. So 28 plus 2 is 30. 6 times 5 is also 30. So that'd be yes, and they are parallel. Okay, so these are the 3 parallel lines. They just want you to fill in the blank with what's equal to it. So no numbers to work with here, and just understanding the formula. So we're going to look for each part. UV is right here, over UW, over the total length. So the top part over the total equals XY. That's going to be over the total then, XZ. We're going to put XZ in there. Okay, so just checking the checking the table and making sure the corresponding parts match up. XY over YZ, so top versus bottom, equals top, UV, over bottom, VW. So that's going to be UV. Okay, pretty simple. Just stick it right in there. Final one, look at your given WU, so the total length, over WV, the bottom half. So the top was the total, WU, so it has to be ZX. We'll do ZX there. Final examples here are your angle bisectors. Okay, we have an angle bisector. That means I can go 9 over X equals 15 over 5. Okay, 9 over X equals 15 over 5. I can also go X over 5 equals 9 over 15. Okay, you have your choices there of what you want to do. cross multiply, I get 45 equals 15x, so I'm going to get x equals 3. A couple more minutes, sorry, unless you need something. So that takes care of those angle bisectors right there. The final example, notice the total length 14. We'll get into a little bit more algebra here. So this example right here, this is 14, it's the total length. We're going to go 14 minus b, the total minus the part. The total minus the part. So how we set this up is I'm going to go 14 minus b over 6.75 equals b over 9. Equals b over 9. So when we cross multiply, that's a b up there, you will have to distribute the 9. So this is 9 times 14 minus b equals 6.75b. 9 times 14 minus b equals 6.75b. So distribute the 9. 9 times 14, well 10 times 14 is 140. So 9 14s should be 126 minus 9b equals 6.75b. Add the 9b over. You're going to get 126 equals 15.75b. Let's get the 126 divided by 15.75, and we get b to equal 8. So the key part to that makes that 8, and that makes this other side 14 minus 8, that's going to be 6. The key part to that is when you know the total and you know one side, the other side is represented by the total minus the part, the other part, the total minus the other part. And that wraps up our examples for Chapter 8. Okay, this is the shortest chapter in the book, so we got through it pretty quick, but we'll take the test and keep plugging right away. Chapter 9 gets into a little bit of trigonometry, which can be exciting. So good work, and we'll see you in class.